Hi, folks. How's it going? Can everybody hear me okay in the back? I want to make sure the microphone's going. Excellent. Thank you. And there is more seating this way. So I'm Scott Dickens. I work on the Windows team. My day job, I guess, is building the platform that powers these Metro-style apps in HTML5. In this session, we're going to walk through lots of sort of end-to-end things. We're going to write a lot of code. And unfortunately, I guess the way the schedule worked out is like this particular talk is like the dreaded after lunch talk. So I hope everybody's like sufficiently caffeinated. But we're going to try to keep this upbeat, energized. We're going to start moving really fast. So without further ado, I see my job here today as sort of the bridge. And here's what I mean by that. In yesterday's session, you guys saw lots of really, really compelling demos. And then you probably took a look at your session list on your brand new Windows Developer Preview PC. And you said, wow, there's a bunch of really technical sessions that follow this. How am I going to get from point A to point B? And so I see this session laying out as basically the bridge between the two. We're going to start with sort of those high-level concepts, and then we're going to immediately drop sort of a level deeper and get into a more technical discussion about exactly how these apps work and how to build them. And we're going to spend a lot of time in Visual Studio coding. And I know they say, it's difficult to talk and code at the same time, but we're going to give that a shot. And we're all going to do it together, which sort of leads into my next point, is that I'm going to assert up front that building these Metro-style apps in HTML5 is simple and fast and straightforward. And together, we're going to build a pretty compelling app in the course of an hour. Now, we're going to move pretty quickly through this, and so here's my plan. My plan is that we'll get done before the hour's through, and then we'll have lots of time afterwards to sort of communicate and talk and ask questions. So I'd ask that you kind of hold those until then. If for some reason that doesn't work out and we use the whole full hour, I promise I will still stick around and answer all your questions. And then after that, I'll go to the expo hall, and we can have even more sort of Q&A back and forth. So here we go. This is sort of our roadmap, if you will, the guide to this particular talk. We're going to talk about 4 main points. We're going to start with a discussion around packaging and runtime, not to be confused with Windows runtime, but sort of the runtime environment of these applications. Then we're going to move on to a discussion around the web platform. And we're going to talk about the features that have gone into the web platform that aid in the building of Metro-style apps. Third, we're going to talk about the process lifecycle. You heard about this a little bit in the keynote session yesterday, and then again in sort of the big picture sessions, and then again in a session that happened in this room like 2 hours ago or an hour ago. But it really is this notion of like we change stuff there based on users' expectations. And so what does that mean for you as a developer writing an app? We'll talk through that. And then the last part is really how do I harness the power of these Windows runtime APIs and call those from JavaScript. And we'll get into some of the mechanics of how that works. And we'll hook up a couple of contracts during the course of the talk. So here we go, packaging and runtime. One of the questions that you may have had after the sessions yesterday is, really, what's the anatomy of this app? Like, what does it really, really look like? Help me wrap my head around that. And so you heard about this notion of an app package. The app package is really the binaries that make up your app. This is the HTML, the CSS, the JavaScript, the resources like image files, et cetera, and a manifest that describes those your application, and that's used during deployment and a little bit during the runtime of your app. So if you think to the development process, you're in Visual Studio, you write some code. Like you press F5, a package is built. And that same package, eventually at the very end of your journey, is the thing that you would upload to the Windows Store. That package would be bought, acquired by users. It comes down to their machine. And then the installer technology in Windows takes that package, expands it out, and puts it on disk. And so that's what you see there in sort of the C program files applications directory. And we'll get into what that looks like when we start demoing. The next thing that happens is the user is going to click on a tile and start running your application. And when they do that, a host process starts up. And so this is sort of the execution environment of your application. And it consists of 2 components. The first is this thing called an app container. And so in the Windows 7 world and in Windows 8 desktop apps, the application itself generally runs with your user credentials. It runs at the same sort of permission set as your user account. These Metro-style applications do not run at that. They run at something less than that. And that entity we'll call an app container. And we'll take a look at how you can find out that your app is running in an app container. I'll show you that. The second thing that happens is that this host process starts up, and that's the execution environment that does sort of the rendering of your app, if you will. That's the thing that processes HTML and CSS and JavaScript. And so I guess without further ado, let's start the demo portion of this talk. So we'll start in Visual Studio, and we're going to create a new project. Well, this is just a blank app. We'll give it a name, and we'll create the project. And because we're sort of only looking at the very most basic part of this application, sort of the execution environment, let's do the typical hello world thing and build and run the app. So there's our very non-exciting app right now. And so in the keynotes yesterday and the big picture talk, you saw lots of this new task manager, like lots of screenshots of that. And you can see an entry here that describes your app. And you can see that it's branded as your app. Like to the system, to the user, everything looks like your app. Let's go a step deeper. On the Details tab, you can see the processes that are really running on the system. And clearly, there's not a Sketch app process that's running. But there is this other entity, and that's the execution environment for your Metro-style HTML5 app. This is the thing that is running and hosting your particular application, the thing that's providing that HTML, CSS, and JavaScript services. So that's sort of that first component of the runtime execution environment. The other part that we just talked about is the app container. And you might say, well, how can I figure out if something's running in an app container? What does that really mean? So there's the sysinternal tools called Process Explorer. It's basically just a visual representation of all the processes that are running on your machine. This is available online. If you search on MSDN, you can find it. And there's a column that's not visible by default, but that you can add. And it's called integrity level. And so let's add that column, and then go take a look at our www.host.exe process. And you can see that the system thinks that this thing is running in an app container. It is running in an app container. And you can see the other processes on the system running at something else, where medium is the equivalent of my user account, high is sort of those elevated processes, system or system processes, et cetera. But this particular application, the execution environment for that app, is this app container, something with less privileges than your user account would have. And that's why, relating it back to sort of the keynote talk, there was this discussion around you need to declare that you're going to use certain things. And that's because, by default, your app won't have access to those. You need to signal to the system that you want to go do that set of work. And there's some great talks throughout the week that sort of get into the internals of how that particular stuff works, like the declaration and capabilities, et cetera. I have a bunch of that stuff linked at the end. Like there's a slide that says related sessions, and I'll kind of note those again. So that's sort of the execution environment. Let's get into what the packaging piece looks like. And so I realize we're sort of fast-forwarding way ahead. Like we're moving forward in time, if you will, to the point where that we've already completely finished our app and that we would go to move it to the App Store. And in the demos yesterday, I think you saw Alesh and John, during their discussion of the platform, go to the store menu. And they created an app package. And we're going to do the same thing. And we're going to build a package to use locally here. So we'll click Next. I'll remember this path. And so you can see in the output here in Visual Studio that it'll start building the project. And we'll go to that directory. Hopefully everybody can see this okay. And they talked yesterday about this notion that all applications are signed, and they talked a little bit about how to move applications to other machines so that you could test them on other devices. And that's really what the output of this directory is about. You could take all of those files over to another machine, run the batch file from an elevated command prompt, and get your app installed. So let's take a closer look at this .appx file, which is really the package that represents your Metro-style HTML5 app right now. And we can rename it to .zip, because the format of that AppX package is the Open Packaging Convention, the OPC format. That's the same file format that we use for things like the docx files and the PowerPoint X files, et cetera. Really, it's just a zip archive, and in that zip archive is a bunch of other files, including a manifest that sort of describes the package. So into the zip folder. And let's take a closer look at this. They kind of showed this a bit yesterday. But you can notice that in my project itself, we have a set of folders like CSS and images and JS, and you can see the exact same set of folders reflected here in this package, including the contents. So like the contents of my JS folder is the same as the default.js here. So what you should note is that everything that's there in that Visual Studio package gets bundled up and put into this .appx file, which again flows to the Windows Store and then down to users' machines. When it gets down to users' machines, that package will get installed. And we'll take a look at what that looks like. There's a new applications directory. And in that applications directory is the list of all the applications that have been installed on this particular system. So let's drill into one of those. And you can see that the contents of that particular directory look just like the exploded out package would be. And so like the file default.html, there's a JS directory, and in that JS directory is the set of JavaScript files. There's an images directory, which contains the images for this particular app. The same sort of folder structure. And so hopefully that gives you sort of the big picture, the anatomy, if you will, of your application, and how it sort of moves from Visual Studio to the Windows Store, down to users' machines, gets exploded out on disk, and then launches into this execution environment. I'm starting the process of moving between machines. You'll have to excuse me. It takes like 5 seconds or something to move, and so I have to remember to press the button ahead of time. And that execution environment where the www host process, that execution environment for your app comes up, and also the app container concept. So that's sort of the packaging and runtime piece in a nutshell. And so moving on, oh, that's surprising. It turns out that was supposed to be a checkbox. And so I guess if you don't have the right font or something, you get a block. Anyway, moving on. And so we're going to talk a bit about the web platform and what that means. And so many of you may be familiar with sort of browser architecture. And most browsers today sort of have this notion of a frame process and a tab process. And the frame process provides much of the UI of the browser. That's the place where the address bar lives. That's where tabs live. That's where, like, and tab management, that's where favorites are, like the bookmarks, et cetera. Like, those kind of things live in this frame process. And then there's this notion of a tab process, which sort of gives you the capabilities of rendering websites. And that's the HTML, CSS, JavaScript sort of core engine piece. And most of the modern browsers have this notion of one frame process and then lots of tabs, processes, each for each tab that you're running. And so you can think of that HTML host process that we just saw in the demo, that www host.exe thing. You can think of that thing as being akin to a tab, in that there is no Chrome around it, for lack of a better word. There's no UI there. This is just an execution environment for your app, a place where HTML, CSS, and JavaScript gets run. And it turns out that we call that core component the web platform. And the web platform component that powers IE10 tabs is the same web platform component that powers these Metro-style apps in HTML5. And so what does that mean to you? It means that all of the goodies, if you will, all of the things that you've known to come to love around HTML5 are just there. And so some of these, like, we sort of glossed over very quickly in the keynotes yesterday, but these are big wins, folks. Lots of these things are brand new now in the IE10 platform, like IndexedDB and App Cache and web workers. These are things that we put into the web platform specifically for enabling the building of really, really rich and powerful apps. So you can think of the capabilities of your Metro-style app in HTML5 as being everything that's available in this core web platform. In addition to that, you have access to the Windows runtime. And so you might say, really, what's different between that browser execution environment and this Metro-style app execution environment? And really, it comes down to simplicity. We've made a set of simplifying assumptions and decisions that get you to building Metro-style apps quicker. The first of those, in the web world, you need to worry about legacy. You have to worry a lot about legacy, in fact. And you have to worry about legacy doc types and legacy browsers, et cetera. In this particular world, you can guarantee that every Windows 8 machine has these HTML5 capabilities. And there's only one doc type to worry about. It's the HTML5 standards doc type. Nothing else. The second, we're really talking about the standards-based web. And so those of you that have nightmares around how do I make sure that clients have the right plugin to run my application, et cetera, this is all about the standards-based web and the power of the standards-based web. And then third, another sort of common programming model on the web is this notion of multiple windows. Most sites have sort of gravitated away from that, and most browsers sort of force you to one window with pop-up blockers, et cetera, et cetera. In this Metro-style app world, you own every pixel that gets drawn to the screen, and it's really one large window, and that's the thing that gets managed. And you as a web developer don't have to worry about post-messaging between windows, et cetera, creating new windows, managing those, et cetera. It's all just one single window. So that's sort of the power of the web platform itself. It's all these HTML5 technologies, and then on top of that is sort of the power of the Windows runtime. There's this other entity that got mentioned a couple times, and I want to drill in deeper about what this means. In the web world today, most of you probably use some kind of JavaScript library. And the library itself has very sort of familiar patterns to you. You use it to get things done quicker. Like everything from, instead of doing, document, like get element by ID, you use the $, et cetera, to, hey, I really want to use XHR, and so I don't want to code a ton of stuff around XHR. I just use sort of the built-in patterns, or I want to do binding instead of add event listener, et cetera. So our library that we produce, this Windows library for JavaScript, does those same things, just in the style of building Metro-style apps. And so the first is a whole set of accelerators, if you will, things that help you interface with the system quicker, easier, faster, better. And so we'll show that in the demo. The second thing that it does is that it helps you achieve that great look and feel. And of course, under the covers, all of this is JavaScript and then powered by some CSS. And so you could certainly recreate it, but by using that particular library, you get a bunch of that stuff for free, which means that you can spend more time sort of concentrating on the core competencies of your app and sort of less time trying to make sure your animation does things exactly correctly or your positioning looks exactly right. And so without further ado, let's see if we can't build a more interesting app. So I'm going to start by sort of I'm going to show something in Internet Explorer, which is clearly not an app, but I think it does sort of illustrate the point and the power of the platform. And so we're going to start by just loading a very, 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 very simple Canvas sketch app. So Canvas, as you know, is sort of a 2D graphics technology. All this demo does under the covers is it creates a canvas, and then I can draw on it. And it's really only one color. But let's use that same code that's powering that particular app to sort of jumpstart our building of a Metro-style app. And so in order to do that, we're going to do a couple things. The first is we're going to add a reference to the canvas.js file. That's really the code that's powering that canvas. It sets up a canvas, allows us to draw. The second thing that we'll need to do is we'll have to remember to actually reference that canvas file in our project. And then the next set of things that we need to do are just create the canvas itself. So we'll create a div to hold the canvas. We'll create a quick canvas. And then the last thing that we're going to do is that the template gives us a set of code. We're going to come back to that code in a little bit. So for now, I'm going to go ahead and comment that out. And in fact, I'm going to use some functionality in Visual Studio to just visually remove that. We're going to come back to that later and talk about it in depth when we get to the point where we've covered the core concepts there. And in the interim, let's just try to get our app up and running. And so as you can see, I'm using some snippets in Visual Studio just so that you don't have to see me typing out on stage. And so that's sort of the technology that's bringing in the code very quickly. And we're going to do a couple things. These function calls are stuff into Canvas.js. It basically just sets up the canvas and allows our app to run. So let's take a look at it. And see what we have. So now we have the same canvas just running inside a Metro-style app instead of inside of a browser. And so what did we learn by that? Well, we learned that, again, this web platform, that same web platform that powers that IE10 tab is the same thing that powers these Metro-style apps. And it's very, very easy to take the code that you already have and bring that over. And there's a great session on Thursday that gets into more detail about how you can reuse your existing assets when building Metro-style apps in HTML5. So that's sort of the core web platform part. Let's add Win.js to this particular project and see if we can't do other interesting things. And so you probably saw in this default template yesterday a reference section for Win.js. And so let's bring in a couple more Win.js files. One that does UI, one that does binding, one that does controls, and another one that sort of controls the animations for all of those things. And so you also heard a lot yesterday about this entity called an app bar. And so let's add an app bar to our project. Now, in yesterday's demos, a lot of this work was sort of done in Expression Blend. And you can certainly use that tool as well. The reason that I'm just going straight to code here is that I wanted to sort of explain the concepts a little deeper. And I think by just looking at the code, that gives you a better overview of how the whole system works. And so as you can see here, really, these are just div controls. And what makes this div special, what makes this thing an app bar as opposed to just some plain vanilla div, is the fact that it has this attribute called winjs.ui.appbar. That's the thing that sets it apart from other divs. And those of you familiar with sort of the HTML5 standard, you may notice that data-win-control attribute. The data-attributes are a set of metadata attributes defined in HTML5. They're for developers to do this exact style of thing, to put in their own metadata that's meaningful, semantic to that particular app. And so now we have an app bar. And you also saw in the demos yesterday that the app bar sort of goes in and out, and that you could swipe from the bottom of the screen and the app bar comes up, et cetera. For demo purposes today, we're just going to leave the app bar up all the time, because we're going to go back to it a bunch, and we don't want to be fiddling around with, et cetera. So we're just going to leave it up. So that's why this light dismiss is sort of set to false. We just want this thing up all the time. So now we have the JavaScript files themselves included in our project, and we have the div. We need to bind the two together. We need to tell the JavaScript, hey, go process this div and make it a control. And the thing that does that is a call to Win.js, if I could type, .ui.processAll. Some things to note. The first is that whenever we're calling into the Windows library for JavaScript, you'll see us use this namespace. It starts with Win.js. That's your signal that we're about to go ask Win.js, the Windows library for JavaScript, to do some work on our behalf. And again, that process all call is the glue, the binding between like our just plain vanilla div and making it into a true app bar. So let's run this thing and see how we ended up. No? Yes. Sorry, pressed the wrong button. So now we have a very sort of plain app bar. But you can see sort of what's going on underneath the covers, that Win.js powering this div and saying, hey, you're not just a regular div, now you're an app bar. So let's see if we can add some buttons to our app bar. And so within the context of that persistent app bar div, we're going to add in 2 buttons. Now, you heard yesterday the notion of placement of those particular icons. And so what we're doing here around touch, and so like as people hold tablets, their thumbs in the reaching area of the thumbs. So what we've done here is we've created 2 buttons. And we put one on the left side, accessible to the left thumb, and one on the right side, accessible to the right thumb. And the one on the left side, its background color is red, sort of very obvious. The other one is, it has an image as a background. So professional tip from somebody who's messed this up a gazillion times. When you reference an image like that, make sure to include the image as part of your package. Otherwise, when you run this thing, it won't be there. So we've added an image, and now we've referenced it. And let's take a look at the app again. OK, so now we have 2 buttons on our app bar. And really all we did was we started with 1 div and told Win.js that's an app bar. And then we added 2 buttons to that particular div, one on the left, one on the right. Let's add a couple more buttons, because right now we can only sort of color in red. So let's see if we can't color in green and blue. So to the same area, general area where we have the red buttons, we'll add in a green and a blue button. They're the exact same as the red button, just different backgrounds. So again, we'll take a look at that. So now we have red and green and blue. So what did we cover there? We covered sort of the richness of the web platform itself, that it's HTML5 powers, app cache, IndexedDB, web workers, and all file API, all of these other things that have been added recently are all there at your disposal so that you can build really powerful Metro-style HTML5 apps. We also talked about the Windows library for JavaScript and how you can use that particular library to jumpstart your app building, and how it gives you the look and feel of Windows, and how it also sort of gives you quicker ways to do common tasks. So that was sort of our discussion of the web platform. And so moving on in our roadmap, we're moving over to this discussion around process lifecycle. So you saw portions of this slide yesterday during the keynotes. And if you were in the session directly preceding mine, you probably saw and heard the full discussion of this slide. Let me start by saying a couple things. Users expect different behavior from these Metro-style apps in two ways. One, they care tremendously about battery life on the system. And so the notion of having all these processes running all the time doesn't really get us the battery life that users expect. The second is that users in this modern world expect to not have to manage the application lifetime. They're not looking for close buttons anymore. They want the system to do that particular work. So what does that mean for you as developers? It means that there are now 3 states for your app. There's not running, there's running, and then there's suspended. And Windows handles the transitions between those based on sort of user intent. When your application is running in the foreground, it gets all the system resources. They're all at the app's disposal. When the user moves your app away from the foreground, Windows says, please don't run any more app. And it sends it a suspend notification. That's your cue as developers to do work. And hopefully you've done work before then, and we'll get to sort of the right patterns. But that's your last sort of cue, hey, I have work to do. Because once you enter that suspend state, you can go one of 2 ways. The user could bring you right back to the foreground, at which point you're just resumed, and your code just continues on. It never left memory. Execution was paused, then it started again. It's as if you had attached a native mode debugger to it and then just said G and go. It's akin to that. The other way that your app could go is that based on sort of the resources available on the system could terminate your app. And then when the user goes back to it, whether they Alt-Tab back to it or whether they click on a tile, like their expectation is that the app is in the same place where it left off. Like they don't know that the system terminated it, and they don't want to know. They just want the app back to the exact same state. So what does this mean? It means that when your app is running, that you need to do work along the way to save off the state of your app. And there's really 3 pieces there, and 2 of which I have on the slide and 1 I'll just talk to. The first is session state for your application. In the app that we're building right now, the Sketch app, we have this notion of red, green, and blue. And those aren't like permanent settings. They're sort of a user preference as they're doodling right now. And so whatever they've chosen, whether it was red or green or blue, if the app gets terminated and comes back, the user's expectation is that, whatever they were using, red, green, or blue, that's back. And so that's sort of the notion of session state. It's not this permanent setting, but it is something that, like, as the user switches around between apps and goes back to your app, they expect to still sort of persist. And so use the session state concept in the Windows library for JavaScript to store that data. And it works periodically. It does work along the way so that eventually when you get suspended, like, you don't have to do a ton of work. It's working along the way. And we'll look at how that works when we do the demo. The second thing is sort of more persistent settings for your app. Like, you could have a configuration option that always says, my canvas is this big, or my canvas is this big. And you could store that in the settings area that you heard about yesterday. And that type of setting, you probably do want to persist. And the right place to store that is windows.storage.application data. I realize that you as web developers have lots of choices about where to store and how to store settings. You could use cookies or IndexedDB or web storage, DOM storage, et cetera, but we were recommending that you use windows.storage.application data. And there's a great talk on Thursday that talks all about sort of the state you're in, if you will, and why to use Windows storage.application data. And then the third piece of data, of course, is the user's data itself, like the thing that they're doodling. If your app gets terminated, they don't want to lose their work. And so the right place for user data is like a user data storage location, like their pictures library, for instance. And we'll get into how that looks as we start building out the app. So again, key takeaway for this, session state for that session data, storage.application data for more persistent settings, and then user data goes in real user data locations. The next thing is that, so you've been saving off work, like as you're running. The next piece is, okay, what do I do when my app is launched? I need to get that data back. And so in the web world, you're probably very familiar with onload. This is like what you include on the body tag and you go do a bunch of work. And just about every JavaScript framework out there hooks body onload and then does a whole set of work. So here's the ordering of events. Onload happens last. And as you can see from this diagram, there's a splash screen that gets displayed when your app is launched. And onload doesn't fire until that splash screen is gone. And so here's what you don't want. You don't want the splash screen to disappear and your app to not be ready. And so you don't want to postpone all your most critical work to onload. That's not the right place for it. The earliest opportunity for you to do work is DOM content loaded. This is an event that was defined in the W3C's DOM L2 spec, and that IE9 supports and IE10 and thus the web platform support here. That's your earliest opportunity to do work. That means when DOM content loaded fires, it means that the whole document has been parsed. But not every image has been decoded, et cetera, but the document itself has been parsed and is ready. Do work there, the most critical work. So that's the work that you set up event handlers, et cetera. And then there's this activated event, and that comes from the Windows runtime. So first DOM content loaded, DOM's ready. Next, activated event. That's your opportunity to go and load that session state. So in the demo that we're about to do, we're going to save off a set of colors, and then on the activated event, we're going to read that stuff back. And then again, the splash screen would tear down when you return from the activated event. And then you could do additional set of work in onload. If you'd like to learn exactly how to optimize this activation path, because it's a pretty key piece to having a great user experience with your app, there's a performance session on Thursday afternoon that sort of discuss how to build these really high-performant HTML, Metro-style apps in HTML5. And they go into like the deep, deep, deep meaning of activation and how it all works. Highly recommend that talk. So let's jump over again and write some more code. So where we left off last time was we had our buttons. And let's go ahead and run our app again, and I'll show you. So we had our red and our green, blue buttons, et cetera. You'd switch away from the app would get suspended. Assume there was memory pressure on the box, and the app was terminated. When you launch the app again, the user's expectation is blue, but we're getting red. And so we need to do a set of work here to match that user expectation. So I know we brought in that canvas.js file earlier. This is the one time that we're going to dip into that file. So we're going to create a global variable called current color. And that's the place we're going to stash away whatever color the user selected. And here we're just going to set current color to be color. So the user is going to select a color. We're going to stash it away into current color. Next thing, we need to do work while our app is running to save off the state of current color. Here's how we're going to do that. First, note that we're calling into the Windows library for JavaScript again. And the event that we're hooking is this checkpoint event. And the Windows library for JavaScript fires this event periodically. And one of the places that it fires it is when you get a suspend event. So for sure, no matter what, like if this app gets suspended, that event will fire, and we'll have time to go save off our state. The next thing that you'll notice is that we're using this session state concept, just as I talked to on the slide. This is the right thing to use for this session state. Then the next thing is our variable. We could call this foo, we could call it bar, we could call it Scott, we could call it whatever. We're calling it latest color. And then we're setting that value to be whatever the color the user has chosen. So now we're doing the right work as our application is running to save off the session state. The other thing that we need to do when our app is running, that was all that we actually needed to do when our app was running. The next thing that we need to do is that when our app launches again, we need to go read this data. So let's go back to the code that we hid earlier and uncomment that and use that. We talked about the ordering of events. And so the work that we did way back at the beginning is we hooked the DOM content loaded event, and we did a set of work, including hooking up some event listeners. Now the next thing that we're doing is we're saying when we're activated, now we're going to go read that session state. Again, in our diagram, the splash screen is still up during this time. So we're going to do work to hook our event listeners. We're going to do work to read our session state. And when we return from that activation event, the splash screen will go away, and our app will be 100% ready and usable. And so you can see that there's a kind, if you will, for the application. There's a bunch of different ways to launch your app. There's tile, there's search, there's share, et cetera. The launch thing is the most basic. It just means tile launch. And so let's add in the code. And maybe we'll do a little bit of formatting here so we can see. So what we're saying basically is, on startup, go check and see if we have this latest color thing, if it even exists. And if it does, well, then we'll call our select color function and set it. So basically we're saying, if it exists, go return the user back to the color that they were using. If it doesn't exist, oh well, we'll just go back to red, because this was session state, not this persistent setting for all time's sake. So let's take a look at this and do a little bit of debugging. So we're going to set a breakpoint on this checkpoint event. We're going to see when the checkpoint event gets fired, and then we're going to check the value of current color and make sure we did all this correctly. So let's run our app. So we're in our app. We're doing red. We do green. We do blue. Blue is the current color. I switch away. Waiting. Our app isn't breaking in the debugger. I wonder what's happening. And so in the keynote yesterday, you saw several times where they sort of brought up Task Manager. And in this new status column over here, you would see a red text, and it would say suspending for your app when it gets suspended. And we're not seeing that. And thinking about it, it actually makes really good sense why we're not seeing that. We're actively trying to debug this application on the machine. And if Windows was aggressively suspending that app, we wouldn't be able to debug it. It would be frozen by the OS. And so Visual Studio helps us as developers get this great experience where we can run the tools and the apps on the same box. Because it tells the OS, hey, please don't suspend this process. I'm actively developing it right now. Thankfully, there is a way for us as developers to trigger the suspend. And that's a debug option within Visual Studio. So from the debug menu, just choose Trigger Suspend. Boom. And now the suspend event is sent. So we're broken now in the debugger. And you can see as I hover over current color, you can see the value of current color. So red, green, blue, blue being 255. So we know that the blue value has persisted. And so that was sort of the work in this particular demo. We did the work to sort of make our app lifecycle aware. We did the right set of ordering for events for activation. We did the right work in DOM content loaded. We did the right work at the activated handler, and we did the right work in body on load. And we also did the right thing for saving off that session state by using the Windows library for JavaScript to store that session state and then reading it back at the activated event when we were activated. So that was sort of our discussion of the process lifecycle. So again, sort of in this progression, packaging and runtime to web platform to process lifecycle. Now we're on to the last piece, the Windows runtime platform. So you saw some great demos. And back to sort of that photo doodle application, the one that Antoine built during the keynote. And so during that, like, he had a Canvas app much like ours, and then he used the picker, this UI that you see right here, to go and get that picture and bring it back into the Canvas. And I bet many of you were asking, well, how does that really work? So it turns out that in the web world, we're very, very used to a currency that is URLs. So like the image tag, you do like source equals and then some URL. And then for the video tags, source equals and some URL. From the Windows runtime, though, the thing that you're getting back is just bytes. You're getting this file object back from the picker, and it's just a raw set of bytes. And so you're saying, how do I take this thing? I just got this set of bytes, but over here I have this image tag, and it expects an URL. How do I get between the two? And the way you do that is this entity called the blob. I didn't make up the name. W3C did. So it's from the file API. And so the blob, the whole intent behind the blob is that it represents this stream of bytes. And from the blob, I can get an URL that then I can use to plug into the image tag and the video tag and the audio tag, these entities that expect an URL. And so, yeah, I know, code on a slide. We'll get to code in Visual Studio in a minute. But just pointing out sort of how this works under the covers. Like the last two lines are the really important ones, where you can see that basically we call create object URL on the file, and we get back a blob URL. And then that blob URL we can use to plug into the image tag. So now we have an URL as our currency rather than just a stream of bytes. Another thing we saw in the demo, and sorry for my really stripped down diagram, was the whole notion of sharing. And so there were two parts of the sharing, right? There was like the source app for sharing and the target app for sharing. And the currency in the previous example was a file from the file picker. The currency in the sharing example is this thing called a data package. The data package is just like this representation of data. And it has many different types that it supports. It supports text, like rich text, plain text, HTML, et cetera. It also supports files. And so let's do the work in our photo doodle sketch type app thingy to hook up the picker. And so we're going to go get a file and bring it back to our canvas. We're also going to do the work to save it out. And we're going to use the blob to do that work. And then we're going to hook up the sharing contract and use the data package as the currency for that particular contract. So let's switch back to our demo machine. And I'm going to remove this breakpoint. And I'm going to collapse some of the stuff in Visual Studio so we can see it easier. So the first thing that I want to do is I want to bring in the code to do the picker. And first off, I'll note, yeah, this is a lot more code. But don't be alarmed. All of the code that I'm doing here and using here is from the SDK samples. And so those of you sitting in the audience going, oh, am I ever going to be able to replicate this? Yes, it's all from the SDK samples. You can just copy and paste directly from there. So there's some boilerplate code here that has to do with sort of scaling our canvas and making sure the image fits, et cetera, et cetera. So I'm going to go ahead and collapse that and move that out of the way. Because the interesting point to talk to is sort of these. The first is, before, when we were calling into the Windows library for JavaScript, our namespace was Win.js. The namespace here is called Windows, note with a capital W and plural. Just calling it out, it confuses people sometimes. So it's Windows with a capital W. And this is our clue that we're calling into the Windows runtime. So anytime you see that, we're making a Windows runtime call. And then the API that we're calling is this thing called file open picker. You'll see this pattern over and over again as you call Windows runtime APIs. Sort of this notion of, I'll call it configuration on top of the API, if you will. You're going to call this picker, and you're going to say, hey, picker, when you open up, I really only want to see images, because that's what we're trying to bring back into the canvas. So JPEG, bitmap, GIF, PNG. You'll notice that this is asynchronous. That's because the picker dialog itself is not part of our app. It's system-rendered UI. And the user's going to take some time to go through the picker and find the file. And while that's happening, we want our app to still be processing messages. We want our app to still run. And so it's an asynchronous API. And you'll notice this then construct. Windows library for JavaScript gives us this. It's this thing called promises. But basically, you guys should think of it as a really simple and easy way to sort of keep your code very readable and sort of top to bottom, even though we're doing all this asynchronous stuff. So just mostly think of it that way. And if you want to get into the exact internals of how promises work, there are some great talks on that particular platform component. And then just like our slide example, the thing that we get back, the piece of currency, is this file. And again, it's just a string, it's just bytes. And so we're going to get an URL from it, and then we're going to plug that into this blob URL, which then we'll plug into the image. And so again, let's sort of do some debugging and see where we end up. Now earlier, we added a button called import, and we basically just hook that button so that we can pull up the picker. So that's where we're at. So here's our blank canvas. We're going to press the import button, and then this is the file picker. This is system-drawn UI that helps the user go select the file. And there are lots of different configuration options. We just happen to choose like some defaults. That's why it goes to documents. You could make it default directly in the pictures library. You can set lots of other configuration on it. So we'll go to the pictures directory, and we'll select a picture, and we'll click open. And now we're broken in the debugger, because we've hit our breakpoint. So let's take a look at a couple things. First is, we have this file object now. And the file object has all these properties like you would expect. We know that this image was a JPEG image. We know its name, the date created, date modified, et cetera. But it's this file object, WinRT file object, a stream of bytes. And then let's go look at the URL that we really got. Now, I realize this isn't the fanciest URL on the planet. It's just blob : instead of HTTP : or whatever. But it is that currency that we need in the web world to plug in as image.source. So now we have an URL to use. So let's clear our breakpoint and continue and see. So now we have the image that we brought into the canvas. Like very, very sort of minimal code that we did to call into the picker, get back a file, from that file get an URL, plug it into the canvas. So let's see if we can go the other way around. Now we have this image on the canvas. Let's see if we can save it out. And so we'll need a couple things to do that. First is, let's add another button. So before we add an import button, let's add an export button. Again, pro tip, make sure that when you add a button that references an image, you add the image itself to your project. So now we have the button hooked up. And let's write the code that actually does sort of the file save. I'll just minimize that other code so we can concentrate on this. So again, sort of more code. But there's a couple key things that I want to point out about this. One, it used to be really, really hard to get a tangible object from a canvas that then you could use. And on the web, sort of before the blob notion came about, like it was just really, really hard to do. And lots of people had creative solutions for this. We've made it really, really easy. There's an MS to blob function. You call that thing, and now you have a blob. And so we did that from the canvas. And you'll see the same idea. We're calling, again, into the Windows runtime. The API that we're calling is this file save picker. Next thing I want to point out, this commented outline. In the discussion yesterday that John and Alesh did on stage, where they built sort of the camera capture app, and it was taking pictures real time and then writing that data to the file system, you'll remember that they had to go into the manifest and edit a little capability that said, yes, I want to use the webcam microphone, but also a capability that said, it's OK for my app to use the pictures library. And the reason that they needed to do that was because the app itself was requesting sort of programmatic access, free will, if you will, to write to that directory. What the picker does is it's not sort of just direct access between your code and the pictures library. It's going through this intermediary, which is UI that's owned by the system. And so in that particular case, we don't need to add the capability. The user, when they pick the file to save, they've complied and they've said, it's OK, app, for you to write to my pictures library. I make that OK. And so you don't have to declare that here. And that's why I was calling this out. It's very easy to sort of fall into the, use this Windows storage, not known folders, .picture library thing. And when you do that, what you're basically asking for is programmatic access to just write anything to the pictures library, which is sort of different than doing it this other way where we're doing file save picker, et cetera. So that's why I called that out. Again, sort of same idea, an asynchronous API, et cetera. The key things to call out next are sort of these two lines. So we have this blob entity, And again, the blob entity is this currency conversion between raw stream of bytes and URLs. And from the blob, we can go one way and get an URL. We can also go the other way and get at the raw stream of bytes. And so that's what we're doing here. We're calling MS random access stream to basically get that raw stream of bytes, because we're going to do a byte for byte copy into this file that we just opened. So we call the picker, the user puts a name in, hits save, we have this empty file item, we have this blob. From that, we're going to get the raw stream and copy it over asynchronously. So that's what we're doing here. So now we have our button hooked up, and we have the file save code. Let's try this out. So we'll use import. We'll select a picture again. We'll doodle on it. I'm not the best doodler. Then we'll click export. So now, sort of same idea with the picker, but you can see that this one is set up for file saving, and it allows me to even enter a file name. So let's enter a name. Click save. Boom. OK, now we've saved the file. Let's go take a look at that using Explorer. So in my pictures library, I now have this export file. And it's exactly as you would expect. It's a PNG that we just wrote out to the pictures library. Again, not a lot of lines of code in order to do that work. So next thing, so that was sort of the blob concept. We also talked about this data package format as the interchange to do a sharing contract. And so let's kind of quickly wire that up. And I say quickly because that's all the code that you need in order to do sharing of this image. That's all the lines. And so basically, under the covers, we're going to hook an event for data requested. That's the event that gets fired when the user clicks on the share charm. That's what you get as the application. And then from that, again, calling into the Windows runtime. And this time, we're going to new up a data package. We'll set a couple properties on that data package, like the title and the application name. But then you'll notice this line of code, which should look really familiar given the last example. Again, we're getting the raw bytes from that blob, and we're just copying them over. The data package supports many different formats again. Text, like rich text, HTML, plain text, et cetera. It also supports files. And we're saying this one is a bitmap. And we're taking that raw stream of bytes from our canvas and then just copying them over into the data package that we're populating. And then we shoot that across as part of the sharing contract. So really, that was all the code. So let's take a look at it. We'll use the same file that we just saved off. So here it is. We brought it in again. And then, using touch, I can bring in the charms. I can also do that by putting my mouse in the lower left-hand corner. And so I'll say, I want to share. Over here in this pane, you'll see the list of apps that have registered on the system as being the target for sharing. Our app is the source. Socialite is now the target. We'll select that, and then it'll start bringing across that particular data package. And as it does, it fills out, and then Socialite sort of populates it in its app. So really, that was like 5 lines of code, and now I have sort of sharing working for my application. A much richer experience. So I grew up in Louisiana, and we have this crazy term there called lagniappe. And it basically means like a little something extra, a little something more. So this is like my one more thing, if you will. Let's work together to build out another unique experience for our application using all the stuff that we've learned so far, the power of the web platform and the power of the Windows runtime sort of working in concert. And so you saw in a bunch of the demos this notion of live tiles, these tiles that sort of update themselves. Wouldn't it be cool if our little photodoodle sketch app thingy could take the images that it knows about and then use those to sort of update the tile? So let's go do that set of work. And in order to do that, we're going to do a couple of things. The first is we're going to dip into the package manifest itself. And Visual Studio does a great job in the default templates of getting me going. But my tile itself isn't really what I want. Like it's this one-by-one thing here. And so I'm going to bring in sort of a larger image. And it tells me the exact sizes that I need. So I brought that in. The next is I have a set of code that I'm going to use to help me do this tile update. So I'm going to add that to my project. And I'm going to remember to reference that code. Now, there's a bunch of different ways that you could probably see this working. You could see periodically as my app's running, I go and update the tile. You could see that I could hook the suspend event and maybe only do it then. But for demo purposes, let's just add a quick button to our app bar so we can kind of control the update frequency. Just makes it really easy to show. And so in our list of buttons here, let's add another button for the tile button. Then last thing, we need to actually bring in the code to do this tile update. Now, I will confess this is a lot more code, but I'm going to break it down into the steps that are happening, and so we can kind of show. The first thing is that our canvas, when we bring in an image, is really big, 10 by 7, 12 by 8, et cetera. But that tile itself is 310 by 150. And so we're going to use a little bit of sort of boilerplate canvas, HTML, JavaScript stuff, basically just to get us a smaller canvas, so a smaller version of that image. And so that's what this code is here. And I'm going to go ahead and remove it out of the way so we can talk about the rest of the stuff. The next thing that we're going to do is that the tile update service itself expects a file on disk. And we have a place for that. And using the Windows Storage APIs, we have this sort of local temp place where we can write our own files. And think of this as sort of more application data type stuff. And again, that's why we're using the Windows Storage namespace. And so we're going to generate a file of this smaller size, the 310 by 150, and we're going to save that particular piece of that file off. And so that's this work here. Then the last thing that we're going to do is we're going to say, OK, now we have this file. We have an URL to that file. Let's go do the work to go update the tile. And so that's when we call this send tile notification. And the send tile notification code is over in this tile.js that we just added. So let's take a look at it. At the top are sort of, again, some more boilerplate code to help us make sure that we don't have naming collisions, et cetera. There's actually WinRT APIs that help do that as well. But the interesting part is really this code, where we're going to call and get a template back. Because as you heard yesterday in the keynotes by Jensen, these tiles themselves are templated. And so there's you could have a big image in the corner and then text, or you could do it the other way around, et cetera. We're just going to do one big image for the whole thing. And so we get back a template. We set a couple properties on it. But the real work happens here, where we take that URL for the image that we saved off and then pass that into this XML tile GUI that we're creating. And then lastly, we say, OK, please go update the tile. So let's take a look at this all in action. So let's bring in a file. We'll use the same one that we've been bringing in all along. And let's go take a look at our tile before we do the update. Uh-oh. I think I messed up something. Let's make sure that I have this right. I do want to make sure that I reference the file correctly. Yep, that part looks right. Let's go back to our app. Uh-oh. Sorry? I think I broke my demo where I did not mean to break my demo. So, what's that? Yeah, I don't know that that's what would have broken it. Because really, the work, there we go. Sorry about that. I think that was just a lag a little bit. And so now we have sort of the image that we had on our canvas before, sort of updating that particular tile. I think it was more of a refresh issue in the start thing. And so with a little bit of work, we sort of put together this glue that kind of took the power of our web platform using Canvas and then the power of the Windows runtime to build out this very, very interesting experience with tile notifications. So that kind of covers our work on the Windows Runtime Platform. So just two quick last things. The first is, I know we called this session sort of HTML5 start to finish, and really, we didn't quite get to the finish line. We went a long way, but there were other things that we could have done. Like we could have put settings into our app. We could have made ourselves a picker target. We could have done snap and rotation and sort of other UX-y type things to really adopt that look and feel of Metro-style apps. But the last thing that I want to leave you with is sort of a call to action. So do take advantage of the rich capabilities that we've added to the HTML platform. These things will help you build really, really rich apps. Do make your app sort of process lifecycle aware. Handle correctly the suspend and resume cases, and do the right work at activation in the right order. And then lastly, do use the power of the Windows runtime to create these amazing experiences. Like we started with kind of a hokey app that was just like this sketch app, but through the power of the Windows runtime, we added all this additional functionality very simply, very quickly, that made the app a lot more than it would have been if it was just this plain sort of vanilla sketch app. So with that, I guess I realized I did go sort of the full 60 minutes. So I'll hang around up here to answer questions, and then I'll also go to the expo hall after that to answer more questions. Thanks for your time.